dive in, I kind of want to preface my talk a little bit with a bit about me, my background. I'm a fish biologist, so at the end of this talk, I'm really going to appreciate any questions that are fish related, and you'll get a best response if they're fish related. That being said, I am addressing a pretty large topic here of assessing climate change risk to cultural and natural resources. This is a broad area of interest, and I'm doing it in a pretty large scale area too, the Yakima River Basin, which kind of brings me into my next little plug, is that my current role is working as the assistant science coordinator for the North Pacific Landscape Conservation Cooperative. And I think this area is actually, this type of work is really related and very interesting to the LCCs, and the fact that we're trying to address a complicated management issue and information needs at a landscape scale. And then lastly, before I dive in, if you like what you see here, we've actually also embarked upon similar work in the Methow River Basin, and that was supported by work from the Northwest Climate Science Center. So I think this is relevant to both LCCs and the CSCs. So with that, I'm jumping in, and what I'm presenting here is actually the culmination of about 6 different papers that came out in an earlier issue of Climatic Change this May in 2014. And I have to say, I was kind of stressed about doing 6 papers in 15 minutes, and then Lisa just did 1,100 papers in 15 minutes, so that kind of put it into perspective for me. Anyways, I am briefly going to hit upon all of these. So the things that we worked on was really how to engage stakeholders on this topic of climate change and natural and cultural resources. And so throughout these series of papers, some of the accomplishments and results were the development of a conceptual model with the stakeholder interest. We did, we looked and helped a lot of people in this with stream temperature modeling, looking at air temperature modeling, and then relating that to stream temperatures in the Yakima River and its tributaries. Steelhead growth modeling, salmon habitat modeling in general, and tribal well-being within this framework. So why the Yakima River Basin? Well, it's got a variety of user groups with very different goals in this area. Tribal interests are to maintain their culturally significant fisheries, as well as it's a huge area for large agricultural interest, pear orchards, apple orchards, hops, vineyards, as well as rangeland in this area as well. And then obviously there's also recreational and natural resources back to the fisheries for private fisheries, as well as commercial rafting. And so the one thing that all these groups could come together with is that they're all concerned about the effects of climate change impacts onto their future water delivery and their natural resources. So this is kind of gives you where the Yakima River Basin is within Washington. And just wanted to point out, this is more forested area. So in the headwaters of the Yakima River, you see about 100 inches of rain per year, and then down at the mouth, you have an entirely different climate area where it's more arid and desert-like, and you get 6 to 10 inches of annual rainfall in a year there. So this is one of those systems that is primarily driven by snowpack and snowmelt runoff for water delivery. And so as I was saying, it's big for the agriculture. Well, the mean annual surface water demand is 2.5 million acre feet, which is a huge number. And this demand is only partially met by some of the snowpack and the river flows, and being that in 5 Bureau of Reclamation reservoirs. So there's a lot of demand for limited resources in this area. So what would a climate talk be without the requisite slides that hopefully you all have been paying attention today? These are, in general, we are seeing warming trends. This is the more, well, some say extreme case, or some say this is, if we do nothing case, you're gonna see increased temperatures. This is a lesser, but in general, what you're seeing is increased temperatures. What does that do to the Yakima River area? Well, as I said, it's a snowpack, snow runoff driven system. So with increased temperatures, you're gonna have increased stream temperatures, and you're gonna have changes in the hydrologic regime. So the water availability, not only just the amount of water, but also the timing of when that water availability will be in the rivers. which is what is illustrated down here. So this is the more traditional hydrologic flow, which had, the springtime freshets more in the early spring, summertime, or May, June, and more water available at that time, shifting with the decreased snowpack to earlier in the wintertime, you would have the earlier freshets, and then in general, less water available in the summertime. And so as you heard from Lisa, temperature is definitely an issue for fish. So you'll have thermal stress for the salmonids. You can have altered growth. This is going to affect overall survival of some of these species, and also could affect the population persistence over time. Some other complications, as Lisa also did mention, is the increased invasive species moving up into these warmer waters and the interactions between them as both being predators to salmon as well as competing for resources. So another thing, of course, being that I'm a fish biologist, this is a bit of a fish-centric talk. But this was our first approach here, was to jump in and kind of develop a decision analysis framework. And so we worked with a couple consultants and held stakeholder workshops in which we had a wide variety of attendees from some of the all irrigation districts, elected officials, federal, state, tribal, fish and wildlife managers, as well as the state water, or federal and state water managers. And so we solicited input from this group as we embarked on this to look at some of those, the physical aspects of the effects of climate change, what that will do to the habitat, and then developing models related to that within this framework. So habitat models, bioenergetic models leading towards population, and what effect that would have on the overall community. Some of the things we got out of this, personally for my work, we were focusing on Chinook. They wanted to know a little bit more about steelhead in the Yakima River Basin for as far as growth modeling went, and we also added temperature modeling from not just the main stem, but also to some of the tributaries in Sadis and Toppenish Creeks. And then we did work to develop a conceptual model of kind of these management issues and overall goals in the Yakima River Basin. So again, this is kind of what some of the work was based on, was previous work by Mark Maston and Ken Bovey in looking at some of these climate scenarios. So those trends that we saw, for some of the models within the paper themes is a baseline, and then basically we did a +1 degree and a +2 degree temperature scenarios. Those were our basic modeling efforts that we worked for. The watershed model was basically, again, looking at how water is delivered throughout the whole basin. And that was, some of this work was already the baseline of where we moved forward from. And so that gets put into this riverware software, and from that we had our temperature models. A lot of this fed into the GIS modeling, creating habitat maps for the fish modeling, as well as our bioenergetics, and again, going down to growth, population effects. And then how all of this affecting the natural resources, again, this is kind of an emphasis on fish right here, but how that will affect social and economic aspects within that region, the Yakima River Basin. So this was the conceptual model that's kind of been developed. This was done in Analytica software, and it was done by some consultants. And so what we have over here, these are kind of, you can think of them as more the management considerations or operations, such as how you run your reservoir operations, or what is the groundwater storage, what can you do for habitat enhancement. So that's what you have over on this side. And then over here, this would be more, what are your goals? Where do you want to end up? Where does the community want to be? And in this case, we kind of just highlighted a path through here, which would be, future climate scenarios being warming temperatures. What might those do to in-stream flows? How does that affect the habitat conditions, the actual stream and river conditions? What does that do to fish health in the Yakima River Basin? How does that affect tribal fisheries? What does that lead to maximum economic benefits for both the tribal fisheries and quality of life in general for the people living there? So it's a complicated system, but you can break it down and populate the model and break down each piece and look at it separately and move forward on this. Another component of this that was built was looking further into tribal well-being. And so again, you can see we're going to focus a little bit here on first foods and mainly salmon, but all of these things here are considered as components that go towards tribal well-being. And there's a whole paper on this one, and again, taking it a little further to see how salmon can go back. If you look at salmon doing well, what are some of the things that lead into that, decisions over here, decisions being made, how they affect all the way down to your salmon and tribal well-being. So complicated, but nice to see broken down, and you can go to each aspect of that. This gets more into some of the explicit habitat models for fish, looking at bathymetry, river hydraulics, and fish habitat. We combined some of the GIS work, mainly coming up with depths and velocities and flows, and developed habitat discharge response curves. So in general, this was for fall Chinook spawning and spring rearing, and so these were done also for coho and for individual life history stages. And flows have different effects on different species and different stages. But in general, you can kind of see that with increased flow, you get increases of available habitat. Here, Gap and Wapato are actually two different reaches on the main stem Yakima, two different reaches, so they do have slightly different effects from the bathymetry and the hydraulic modeling that went into that. But here you can see at a point too much flow may not be necessarily a good thing as it starts to go down here, but in general, more flow is better for habitat. Oops. So they were able to take this information, compile it all into looking at our future scenarios. So this here was basically a scenario of no change. This is that +1 degree scenario and +2 degree scenario. And this is just, again, looking at Chinook spawning a habitat. And so with increased warming, looking at the combined habitat criteria, you're going to see a decrease in available habitat. And again, you kind of see that trend here for the Wapato Reach as well. So what you can do with this, though, is then do some sensitivity analysis and look at alternate management scenarios. So knowing that you have this information, what could you do if you were to, say, decrease water even more in this gap area? What does that do? And here it actually looks in this particular reach, it actually increases the habitat availability. And same with the Wapato, taking your existing models, and you can look at a scenario of increasing water and what that would do to the habitat in that area. So this allows us to kind of consider some of the trade-offs of different management scenarios in respect to fish habitat. So we also did some bioenergetics modeling, I said, looking specifically at steelhead, and basically the big factor that you're looking here is growth. So looking at energy inputs, basically everything that the fish consumes, subtract away the cost of living, your respiration and waste, and you get growth. And we used modeled stream temperatures to do our modeling, and this is our basic results from that. And what we started out with our inputs were, as I said, modeled stream temperatures, again looking at a +1 and a +2 degrees Celsius increase in temperatures. Fish size and diet data were from the Yakima River Basin, generally in the field, and they were for steelhead, mostly age 1. We also did some work on age 0s, but this is the age 1 data, and we ran some 1-month and 3-month model runs for the spring and the summer. And you actually see, compared to what the baseline would be, so this is the % weight change from what would be your baseline temperature, is that you actually get increased growth in those early season in the March, April, so a little bit warmer temperature, if you have a constant diet, is actually a good thing. And then we actually didn't see really any change at all in April, and then as you see, as it starts to get warmer, at some point it gets too warm for them to where that the metabolic costs are increasing, and then they're actually losing weight. And so you can see that here much more in the later months in July, August, and September, that they are actually decreasing weight in all of those months and an overall decrease in weight. So kind of some just general overall conclusions from this rapid fire assessment of all these different papers. The effects of climate change on salmon habitats was really dependent on species and life history stages. I only presented some of the Chinook stuff here, but, and also on some of the reaches. So you really do need to consider specifically the species and the life history if you're concerned about a species. But overall, we did see kind of a downward trend in habitat abundance and a decrease in the potential habitat persistence within the Yakima River Basin with these climate change scenarios. And that summertime is going to be the particular area or time for bottleneck period for salmons, because that's when you're going to have the low flows combined with the higher temperatures and overall decreased available habitat. And from that, you're going to get that altered growth and perhaps issues with population persistence. But some of the good things with some of that habitat modeling and looking at the sensitivity of different management scenarios is that there, you can do something, kind of as what Lisa was saying as well. Things you can do is keep streams cool, really maintain your riparian corridors, manage flows for fish as much as possible with, of course, the trade-offs of agriculture and the other things to consider. Fund stream restoration projects and really maintain ecosystem function. Because one thing we didn't really get into here is that if you have great food sources for fish, some of those losses you see in growth may be compensated for if there's enough available food, and that's an area that's kind of an unknown as to what the impacts of climate change are on the actual food source for the fish. So kind of our accomplishments, this was a multi-agency process, many different disciplines working together, and we were able to, in a relatively short amount of time, develop a conceptual model that really expresses the stakeholder interests, and it allows for this development of a decision analysis and support tool that can help managers really understand trade-offs under the climate scenarios, and then those potential critical time periods, such as that summertime period. And with that, I just wanted to really acknowledge this is a list of all the co-authors of those 6 papers that are available in climatic change, and also acknowledge Washington Department of Fish and Wildlife and Yakima Nation Fisheries, who also supplied data for this project. And as I said, we had 3 different USGS science centers, Columbia River Intertribe Fish Commission, 2 consulting firms, consulting businesses, and I think that's it.